Thanks everyone for joining on our 7th episode of the Power Hour webinar series, brought to you by Scanware. Hopefully everyone knows who I am. We've done enough of these, but if you don't, I'm Dan Henderson. I'm the Global Head of Electrical Safety and Partnerships here at Scanware. I'm a Chartered Electrical Engineer based in the UK with a wide background of electrical engineering and electrical safety. I'm joined today by Anthony Long, who some people may know, but he hasn't been on here for a while, so I'll hand you over to do a bit of an introduction, Anthony, just the
Yeah,
cobwebs off.
thank you, Daniel. So I was back on here last I think about June last year, I think it was. So yeah, not been on for a while. Been on as a spectator, not as a presenter. So yeah, I'm Anthony Long, one of the founders of Scamware. Been in the business for too many years to number these days. It's like candles on the birthday cake. But yeah, I'm leader of the technical team at Scamware, mainly focusing on product development and making sure that people are wearing the right gear to keep them safe. But glad to be on today. Thank you
Oh,
all.
good to
Thank you
have
for
you.
joining.
Thanks, Anthony. Right, so we'll go through the housekeeping. So just so you know, if you have registered for the webinars, you will receive the slides after the webinar via email. You'll also get a recording sent after the webinar. Please use the post-webinar survey and use the Q&A as well. Let us know how we did. We'll go through the topics that are coming along. If there's anything, they're not set in stone. So if there's anything that you think is more pertinent, if you're thinking it, others might be as well. So let us know if you think there's other topics that we should be looking at. Do make use of the Q&A for that and get involved. We can always learn from each other. So there'll be times where it'd be good to get some of your experiences put in the Q&A as well. And if you want to be enrolled for future sessions, just let us know in the chat as well. So just to go over a bit of a timeline around this Power Hour series, obviously we started these last year, and we've been breaking them, like the topic's massive, isn't it, for electrical safety? So we've been breaking that down into bite-sized chunks, starting off right at the beginning. So building your asset lists up, talking around how to set up an initial electrical safety program, using that asset list to interpret into requirements and identify risks in your workplace. And then we've jumped around a little bit into things like investigation of incidents and things like that, protection surveys, arc flash surveys, and trying to understand that information. So we're just continuing on with our timeline, breaking down those topics into bite-sized pieces so we can interpret them, take them away, and then build on them in future sessions. So this year, we've spread them out a little bit more rather than doing one every month, as you'll see on the timeline. So the one that we did last time was focused on power quality and the impact that it has on electrical safety when we're overloading our networks and some of the impacts that that can have. So it's a really good topic, and I don't see it enough in relation to electrical safety. So I thought that's where we would start, just to introduce that. Today we're looking through substation entry and how to do that safely and relate that to the PPE requirements for going into the spaces and understand those labels. We're going to be looking a bit more specific at HV switching and managing control boundaries on networks in the next session. June might be a bit contentious. Hopefully we're going to be working together, looking at the differences between how we manage maintenance outages and things like that between the UK and the US. There's some key differences that I'm starting to see the more that I'm working with our US customer base. And hopefully we're all friends at the end of it. We're doing it to try and learn from each other, best practices, learn from things that mistakes that we've made in the past. So hopefully that should be a good session where we can side by side the way we do things for certain scenarios that are quite common in our industry, and we'll all be friends after, I'm sure. We'll look at some of the near miss stuff in July, and how that interacts with human factors on a lot of occasions. We're going to be looking at some of the condition monitoring elements later on in the year, especially around increasing awareness of things like non-invasive testing methods, just to try and give you a better oversight of your networks and how they're how they're behaving, I guess. There's a big focus this year. You'll see this as we go through things in our conferences or some of our discussions. We're trying to focus the risk on the guys that are at the pointy end. So we will be referencing more people in field service or our APs or SAPs or competent persons, the people that are affected by the risks within electrical rooms, electrical substations. So we're trying to drive that awareness. So we're going to have a session specifically around that in October, and then we'll finish the year by bringing it back around towards competency and authorization. So today, learning objectives, hopefully we're going to understand the hazards that exist within substations, switch rooms and compounds, understand the precautions to take when entering an electrical room, understand how to identify the correct PPE for the task within the room, then understand the garment label and how it correlates with the arc flash survey or the instant energy survey to ensure that you're correctly protected when you're in there. So hazards, just to start off, we all know it's something that has the potential to cause harm. So just to, suppose, get you involved, if I'm just going to play a little video, if you can have a look and let us know what hazards would you consider in this space, in this outdoor transformer compound.
Type away your hazards in the chat box. Good to hear from you all.
Yeah, drop them in the chat. So it's an outdoor compound, exposed conductor. It's 66 kV. There's 2 transformers in that compound. Just interested to see what sort of hazards we'll be looking, what would be considering if we were going into that compartment. Obviously, it's going to depend what tasking we're doing.
We've got electrical risks here down, explosions, outdoor risks.
Yep, there's a clear electrical risk or danger of electrocution. That's exposed conductor, so that's live 66 kV conductor there. That's not insulated. Working at heights would be massive. It's definitely something to consider. So safety distances, interference from public. It is outdoor in an area. It's fenced off. It does comply with our ASQCR regulations, so I'd like to think. But again, you can't stop people going where they want if they've got the intent. Yep, aerial and shrouded conductors. Yeah, so exposed conductors. So safety distances would be a key thing we'd have to be looking at. Induced voltages, yes, definitely. Yeah, so we've got oil-filled assets there. They're quite aged, as you can see. They're a fairly vintage piece of kit. So again, if there's any issues, if there's an internal fault, a catastrophic failure, there's definitely potential there with the oil risk. Weather, massive one, yeah, definitely one to consider. It's outdoors, and typically if you work in there, it could be you know, it could be intrusive. You could have a big setup there. Definitely, if there's a change in weather, lightning, high winds, rain, things there. Difficult for maintenance. It's not that rough a surface. It's no, it's I suppose it's not level ground, so potentially things like scaffold or hop up platforms, things that might be difficult. That's all really good. Thanks very much for your inputs. It's appreciated. And then what about this? So we've got 2 indoor substations with switchgear. So the top picture is oil-filled indoor switchgear at 11 kV, and underneath we've got vacuum switchgear again within an internal substation. Not sure the voltage on that. Might be 13 kV. Vacuum gear. What hazards would we consider? Throw it in the chat. We'll summarize these, obviously. I'm not just asking you guys to do the webinar. Although that would be a good approach for future ref. Yeah, what insulation medium? So on this one, the top switchgear is oil insulated. So we've got an oil risk. Bottom one's vacuum.
Yep, arc flash.
Yeah. Yep, arc flash. Restricted access. Yeah, you'll see there's no markings there to indicate where the restricted access boundary is. Manual handling, racking in and out. Yeah, sometimes they're not the easiest. ergonomically.
Especially the old ones.
Solid though.
Yeah.
Lighting, yeah. So it's never at a premium especially in indoor spaces. It's like maybe one or two strip lights typically, depends on the age of the substation, but it's never something that's given a massive amount of, yeah. So definitely lighting can cause it's a hazard there, something that can potentially cause a risk. Yep, adjacent circuits, doors left open, rubber matting could be a trip hazard. Yeah, it's there for a reason, but again, it could introduce another hazard into the workplace.
Hosing open the wrong cabinet. Absolutely. Correct.
Yeah, this is why it's a really good point, and that's why it's important for your labeling to be correct. You can see there that those panels are labeled, but in one of those examples, I know that it's not actually marked up. There's no label on the rear of the panel, which again, if you're working at the rear of a panel, that's where you're on the opposite side of the board. You could get confused and you could remove the wrong cover. So it's a really good point. No, that's brilliant. And if we just one more, then you finish the webinar. Thank you. So this again, these are two indoor transformer compounds. So one's got fluid-filled transformers there. I think there's a mix of mineral oil and synthetic oil, and then we've got a cast resin or dry transformer at the bottom, and that is I think that's in Europe. That one that's inside an indoor compound, but the door can be opened anytime. It's not interlocked with the switchgear. So that again, that's a exposed conductor risk when you're opening the door, and that's right in front of you. Yeah, 100% exposed conductor. So a lot of the time,
access as well.
Yeah. So with them exposed conductors with cast resin, a lot of the times they're interlocked with the ground switch or the earth switch for the circuit breaker feeder for the transformer. So often then once you've got that in circuit earth or circuit ground, you can then remove the key, which then opens up that compartment. In this case, it doesn't, and there's just a plastic barrier across the front. So again, safety distances, massive one there, Joe. Thanks for that. Definitely a good point for that one. Exposed conductors, definitely. Poor lighting, they're terrible in that location. And then obviously you've got a large accumulation of oil as well in that compartment. The one on the top, that's I think there's something like 15 transformers in that one compartment. So there's quite a lot of oil as well to potentially accumulate. That's why that customer's put in fire barriers between each transformer. Yeah, definitely a massive point. ID of equipment. It's such a basic thing, but something that causes such a massive issue. No, it's really good. I really appreciate that. I think it's definitely good to get your inputs on these, because if there might be something that I haven't thought of or something that you guys have come across that's totally different. So no, I appreciate that. So yeah, as we've gone through, something that has the potential to cause harm, and most things you've already mentioned. But slips, trips, and falls is the nightmare for any health and safety professional. But again, for us, there's not many people. Substations and switch rooms and compounds, typically they should be seldom accessed. You know, people should only be going in there when there's interaction with the gear. So whether it's doing an inspection, a survey, or whether you're doing maintenance. But often when you're in there, you've got a limited window. So if it is an outage, you might introduce a housekeeping issue where you've got trailing leads for test equipment, even vacuum cleaners, things like that when you're doing maintenance. And often you're not going to tidy typically before you restore supplies. Normally your time's at a premium when you're having an outage. So when you're trying to get the power back on, then as an afterthought, then you address your housekeeping after. Now the best the most diligent engineers out there will, I'm sure, but under time pressures and things like that, often the housekeeping side gets left. Raise floor plates when you've been doing, checking for water ingress in cable ducts and things like that, or even doing repairs. These are all things that introduce this slips, trips, and falls potential in these spaces, and it's something that's always prevalent within substations. Access and egress. I think someone mentioned it earlier on, space is often at a premium. So when we're building, new factories, new substations, things like that, yeah, new data centers, where the switchgear is going is often not a massive consideration. It's just built against the design of what you've got. All the areas where VIPs go, or the typical VIP route will be nice and spacious and things like that. Substation switchrooms and compounds are normally built to a size. More often than not, they'll be built to the design. The design often changes. We'll put a couple of extra panels on there for future. So already you're limiting the space within there. And another thing to consider, so you always need to be aware of what your access and egress routes are within the rooms. How do you get in? How do you get out, especially in the event of an emergency? And an additional consideration when you're doing maintenance, especially for withdrawable gear, potentially where you're going to restrict your access and egress points as well. Control of other persons, not necessarily just unauthorized persons, authorized persons as well. So knowing who's in the compartment, what works are ongoing. So if you've got the bottom left picture is a substation with an industrial facility. So you've got a 6.6 kV motor control center, LV switchboard, cast resin transformers. You've also got a lot of variable speed drives or variable frequency drives as well located in that compartment. So you could have multiple on an outage, which again we've mentioned are at a premium. They don't come along very often. To minimize downtime, you're going to try and maximize as much as you can in that window. So it might be that you've got people maintaining the variable speed drives, the cast resin transformers, the LV gear, the MCC. You could have multiple work parties in there, which again introduce hazards that individual work parties or work planners might not have considered. So control of authorized persons is just as important as unauthorized persons. And unauthorized persons, again, someone mentioned it earlier around unauthorized access. So these are authorized controlled areas because of the risks and hazards that we've mentioned already. If the door is open, people don't tend to go in there to cause with malicious intent. People are curious by nature. So if there's a door open that's not normally open, people do tend to go in there. We've had so many cases where people have gone in and accidentally hit an e-stop and tripped something that's been under high load. Or cleaners, again, a cleaner won't go in there with malicious intent. They might think, I've never cleaned in there before, I'll go and give it a wipe over. And that's where we've had issues in the past where unauthorized persons have accessed them to try and do the right thing, and they've actually introduced a massive hazard into the compartment. So room integrity, control of the doors is massively important. Weather, again, this was mentioned specifically for outdoor compounds, high winds, rain, lightning, just making sure you know what your emergency response plan is in those events. Shouldn't really impact you for indoor unless you've got leaking roofs and things there, which hopefully you haven't. Electric shock goes without saying. So exposed conductors, removal of covers to exposed conductors, batteries, obviously they're typically exposed conductors unless you've got shrouding or some kind of screen there. Asphyxiation, maybe not as common anymore, but again, depending on what fire protection systems you might have an asphyxiation risk, things like CO2 or I'd like to think older ones like BCF and Halon aren't anymore, but you do see CO2 quite a lot still on networks, which doesn't support life. So making sure that you've got a process for isolation of those systems. Explosive gases, so potentially from batteries or in the event of a catastrophic failure of oil apparatus or oil-filled switchgear, oil-filled transformers, things there. And obviously the catastrophic failure of switchgear, arc flash, so again, which is a low frequency event, but obviously high consequence in the event that it happens. So we've looked at the hazards. We know the risk is the probability of the event against the consequence or the outcome of the event, so the severity. So we're going to look at what other considerations would affect that probability. If you want to put in the chat what you think we should consider, and I'll just start going through and we'll see if there's anything that I've missed, anything that we can add on. So environmental conditions. So typically we might have a plan around how we're going to make the system safe, but environmental conditions can often be out of our control. So like we've said, things like if it's outdoor, things like weather, other people, changing in conditions. It might even be things like humidity, things to consider. So when we're talking about things like arc flash and stuff like that, there are things, so there's a direct link between humidity levels and PD, which leads to tracking, which often leads to flashover. So it's about considering those different things, what's going on in the area, so whether there's adjacent works, whether there's you might be close to things like crop fields, where they're cutting down crops, which again can introduce debris into systems, which then result in flashover. So all of these, the temperature, the weather, all these environmental conditions we need to consider, as that might affect the probability of a risk and potential harm to persons going in there. The maintenance condition. So again, if you own your own network, control, operate, and maintain your own network, then strong likelihood is you're going to have a really good idea around the condition of your assets, any issues to keep an eye out on. But for people, in field service, as an example, or when we use third-party contractors, they're not typically aware of that, and often they won't ask the questions either. So maintenance and the condition of the equipment is a massive consideration that could affect the probability of an issue. The operational condition. So again, how often has the circuit breaker, for example, been in that same position? So has it been closed to on for a number of years and not cycled? Because again, if it is, that's potential where last time it was maintained, everything worked, but if it's been sat in the same operational condition, there's potential that it might not operate as expected in the event of a fault. Likewise, depend on that environmental condition. It could be dusty. You could have quite a lot of debris in there, within your mechanical components. You could start getting like verdigris things there, which again prevent that operational condition or impact the operational condition of your gear. Are the drones up to date and correct? This all kind of links back to, again, if you control, operate, and maintain your own network, the likelihood is you're probably going to have a drone that's up to date, or you yourself might know where it's not up to date. So you might then be able to, these little niche things. And this is, again, comes back to making sure that you're applying succession planning, things for other people, because if the person that knows this information, it's in the head, isn't available, or they're sick or something like that, and you haven't got an up-to-date SLD, it's putting other people at risk. Likewise, knowing the maintenance conditions, tracking the history, things like that. So it's important to make sure that your drones are up to date and that they're correct. Any operational restrictions on the equipment? So we talked about these a few times now, around where you might have a suspension of operational practice or an operational restriction on a particular type of equipment. Let's say they come from the manufacturer, or it's come through a system such as the ENA, Energy Networks Association, through the NEDIS scheme. So again, is there any operational restrictions on your equipment that might impact the safety of the persons or how you access the space? Competency of persons, and again, we're going to kind of come back to this, but competency of persons relative to the task. So if they're going into the space, it might be a substation that's being painted, as an example. You wouldn't expect the painters to be fully qualified HV senior authorized persons to access the space, but obviously they've got to have a level of competency, not just in painting, but obviously understanding the risks that go with accessing the space that they're working in and any mitigation that they need to apply in that as well. The knowledge of persons, again, appropriate to the task that they're doing, appropriate to the role that they're going to be doing whilst they're accessing the compartments. Training, again, directly linked with that. They don't have to be, do a HV switching course to access a substation compound or switch room, but they will need to be made aware of the risks, what limitations that they can do, what they can't do, where they can access, where they can't access, that sort of stuff. And it all forms part of this competency of persons piece. Any engineering controls or design. So again, that this newer networks will have a lot of different elements built in that protect people and impact the probability. So whether they're older systems, they've got electromechanical relays, whether they've got electronic relays, whether you've got arc flash protection, whether it's an arc rated board, which diverts the blast in the event of an arc. There's lots of different considerations that might be put into place. Maintenance switches, as an example, to reduce the pickup time and reduce the instant energy. So there's lots of different things that form part now of our engineering controls and our design to try and keep people safe. And the list goes on. It's non-exhaustive. That there could be many others. Again, we've got some in the chat about chemical contact, skin conditions. Yeah, lots of things in there. That's brilliant. No, I appreciate your inputs. Thanks very much. So where do we go from here? So the electrical safety program is the key piece that's going to direct us to keep people safe when we're focusing on this bit of accessing the space. So our electrical safety program, as we know, is going to be made up of safety rules, procedures on how to interpret those safety rules and relevant parts of that into manageable instructions, key definitions, which are so important to keep constant across the whole range of the electrical safety program. For this piece that we're talking about now, access requirements. So who can access, where they can access, when they can access, and what requirements they need to do. Asset lists, we spoke about this in depth. So the asset list part often gets overlooked in electrical safety programs, but this comes back to type of equipment, measures that you might take as an example. So that asset list, the first video that we watched where it was panning across an outdoor substation, if we had the asset list for that, we would know that both of those transformers had automatic tap changes. Automatic tap changes, again, operate automatically based on output of a nominal voltage, which changes with load. So if we're going to go into one of those compartments, a key precaution might be to put those automatic tap changes into manual as an example, so that if there's a fault in the event of when it's changing tap position, it's not going to actually operate when you're in that compartment. We wouldn't know that without having the asset list. So it all forms part of the electrical safety program and into your entry requirements. The training requirements, obviously, that we've talked about, and then a nomination process. So how you actually appoint someone who can do a task, even if it's going into a substation to do a role. So just briefly, when you have got your electrical safety program, we talked about definitions. There's going to be such a range in definitions across the board, but it's important that you understand what your definitions are and you understand how they form part of your electrical safety program. So for example, high voltage in the UK, what we define is over 1000 volts AC or 1500 DC, or is it? So in other places, such as the US, it might be over 600 volts AC. And that's so that, again, when you're putting together your electrical safety program, you got to make sure that the local variations are considered and understood there as well. So make sure what the differences are. Likewise, LV, other places like US, it might be 600 volts AC, maybe 750 in places like Canada as an example. So it's really important to understand what your definitions mean and how they're interpreted and that they're consistent across your program. So some ones that I reviewed very recently, I've reviewed these for a customer looking after data centers, and the reference within there was that they only operate LV equipment. Then when I went to their site, they had MV equipment in the location that they were, so it was over 600 volts AC in the US. So how do they operate that? What they actually do functionally doesn't match the electrical safety program. So that they all need to match. It needs to match what the business unit is, how they work, and make sure everyone understands those definitions. What a substation is, again, they can all have different definitions by locality. So it's really good to have that in place so people can understand. Likewise, we've got different types of compounds. So we've got substations with exposed conductor, like we can see there. We've got enclosed conductor when you can't physically come into contact with the parts. Then we've got things like cast resin transformers, which have got exposed conductor, but you've got safety by limits. So you've got a cage or an enclosure around there that you can't access. That'll be linked in with the protection system, hopefully interlocked. And then you've got visitors, obviously. So visitors want to go in, then we've got to make sure that they're suitably accompanied or they've got a level of authorization to do the task. And some of the things we talked about before, things like cleaning, doing meter readings, that sort of stuff. So before you go into the compartment, we need to make sure you're either accompanied or have a lone working procedure. Again, they're not normally on the normal route. We've got substations that are normally tucked away. They're in the middle of nowhere. They're up on mezzanines. So it's really important to let people know where you are. Confirm the name of the substation. Are you at the right place? And again, this might sound silly, but depending on what the environment's like, sometimes they're directly next door to each other. A lot of the switchgear is very common. If you're in renewables, things like wind turbines, they all look exactly the same, other than a differentiation on the door, on the naming convention. So make sure that you're in the right place. On an offshore wind farm, I got dropped off at the wrong turbine, even though I was told it was the right turbine. Climbed the tower, got everything plugged in the location. I was just ready to open the breaker, and I just double checked my switching program against the nomenclature on the switchgear, and I was at the total wrong one. So if I'd operated that switchgear, I would have turned off the site. It was still under load. Again, an oversight, but when you're doing multiple switching operations, it's just a really easy mistake to make. So make sure you're in the right place. Pay attention to any hazards, so things like signage on the door, any fire suppression systems, operational restrictions. So there's certain operational restrictions that might impact how you enter a space. There's a certain type of switchgear at the moment which has an operational restriction linked with PD. So there's measures in place there where when you get to the compartment, you'll do a partial discharge survey from the door. Then if you're not picking anything up on partial discharge, you'll then do a full PD survey of the gear before you even continue with what you're doing. So it's important to know if there's any operational restrictions on the types of equipment that you've got to make sure that you're safe when entering. Look for signs of forced entry or signs of distress, such as like louvers or vents blown out, and feel the surface of the door for excessive heat. Again, I like to think your fire detection system would have given you a notification, but some of these are in remote locations. You might not actually identify there's an issue inside. And now that you're at the door, I'd like, hopefully we would have had an arc flash survey done, and we'll have a label indicating the type of PPE and what they might look like. So I'll now hand you over to Anthony, who can take you through understanding the PPE requirements and comparing that with the garments.
Thanks, Dan. So yeah, just rolling back on that slide there as well from Dan. So there might be a lot of people that haven't had an arc flash survey done to bring up the incident energy. So you might be kind of walking into a bit of an unknown. So again, you're not on your own if that's a situation for the sites that you work on. I know there'll be a lot of sites that are like that. So it's making sure that you've got something in place, some system in place to understand what levels of fault may occur within that substation. But I guess it goes back to what Dan mentioned earlier about knowing where you're going to be actually working in the first place. So doing that pre-work check, and it might be a couple of days before if you know some work's coming up, to make sure you're assessing what the hazards are. And if you know that a site hasn't got an arc flash energy study, then you're making sure that you're finding out what you need to do to actually know what requirements you need to protect against. But yeah, next slide, Dan. So number one we're dealing with is an arc flash. So arc flashes, they can happen anytime. Obviously extremely high temperatures, molten metal debris from the arc flash creation, lots of noise when you go from a solid state metal to liquid or vapor, you get a lot of noise from that. Bright lights, UV and IR, and then obviously it's not common, but the consequences can be catastrophic to the work of the clothing ignites or melts. So we do a lot of day wear. It's designed to be like workwear, but if you watch the video here now, these guys are dressed in arc flash PPE. They've got helmets, visors, balaclavas on. They've got the gloves on, and they're working on this equipment that would appear to be live, and it looks like they understand it's live as well. So that's the arc flash, but if you look at the actual replay, so obviously yes, don't put a bound around the back of your legs, it might be a tripping hazard, but there's two elements to this arc flash. So if you look at the first bit of the video now, and then the ejection of the shower of sparks. So first of all, you've got a huge mass area of heat as the actual arc takes place, and this is obviously what creates the most of the burns. And then ejecting from that is all the molten metal debris, which looks like a firework party. And that's generally a lot of molten metal, which then can stick to clothing and burn through clothing. So when we're testing clothing, for example, you know, a fabric might be really, really good. A fabric for arc flash might be really good at withstanding heat, but then it might not be very good at withstanding molten metal, or molten metal might stick to the fabric and then cause later burns through the fabric. So we have to analyze both those things when we're looking at actual clothing protection. But as you can see in the arc flash, obviously a lot of heat is generated in that, and both these guys here, they're able to stand there looking back at what just happened. If those guys had been in clothing that caught on fire, it'd be a completely different story and outcome. So fortunately, these guys will maybe feel quite warm possibly. But in the main, those guys would have been able to go home from their shift or continue to make the area safe, because ultimately speaking, they would have had to come back to this project another day to repair the damage that's been done from the arc. Just move on then. So in this situation here, the video we've got on the screen here now, two articles, two mannequins both sides. Left hand side with the light grey top and the grey trousers, that is our Arc Flash PPE. Polo shirt was 12 cal, trousers were 10 cal. On the opposite side is just regular workwear that a lot of electrical workers we see are wearing. And so this arc is generated at 14 cal, so it's actually higher arc rating than the polo shirt and trousers are rated for. But on the opposite side, obviously, just polycotton regular work trousers that you would get from a normal clothing store or supplier. So the left hand side, our garments, you can see it's charred across the front, but it's not broken open. But on the opposite side, you've got a person on fire. But those garments weigh the same amount as each other. So whether you're wearing the polo shirt that's on fire and the trousers that are on fire, or the Arc Flash gear, you've got the same weight. So even when the Arc Flash rating is higher than the product, you're always going to be in a better situation than when you're wearing clothing that's going to ignite and burn. So you understand the method behind burn injuries. The longer the exposure to heat, the deeper the burns go into the body. And so when people catch on fire, generally speaking, it's catastrophic. And even if you're burnt from an Arc Flash, wearing Arc Flash PPE, the burn injury is going to be very, very minimal compared to what happens if you get caught on fire and someone's going to put you out at the same time. So making sure the clothing is correct is absolutely key. Making sure you've got clothing that's inherent, that's not restricted by washing conditions. If you've got garments that tell the wearer that you've got to not use certain conditions or softeners or whatever, then that's a red flag. Because ultimately speaking, they're saying don't use those because it's going to interfere with the actual FR properties of the garment. But if you use a truly inherent FR fibre within the garment, you can wash the garments any which way you like. It might affect the appearance of the garment, but the actual protection remains the same as when you first bought it. So never deteriorate, never wash out when you're using inherent fabrics. So making sure that if you are then going to provide people with Arc Flash PPE, you provide them with PPE that is actually going to last and not going to degrade over time. If we move on to the next slide, please. So here's a couple of label instances I referred to before. So here you've got the first label here that the garment may lose flame resistant properties if it's not laundered and maintained in accordance with manufacturing instructions. So very, very prescriptive. Next label along, you've got do not remove. It's the durability of the flame resistance of this mount burner fabric is guaranteed for the life of the garment, provided that all recommended laundering instructions are followed. So again, if you were to wash it slightly wrong, they're going to also negate that actual warranty that they're giving you there. And then the next label, you can see it says 100% cotton. Cotton has never been flame retardant. It will resist heat to a degree, but then after a while it will self-combust and it will burn. And then the last label there, again, another red flag in that situation. You've got the do not bleach, not use starch, fabric softener. So all those normally in a treated fabric, the issue you have with those articles is that they leave a residue often within the fibre, or they weaken the fibre, and as a result create a hazard for protecting against the Arc Flash. But if you actually use a fully inherent garment, there's no way you can deteriorate the actual quality of the garment without damaging the fabrics manually. But no washing would damage it. It would actually help keep the garment clean and protect you. And if we can move on to the next slide then, please. So ultimately speaking, is making sure that you choose the right garments. So you're looking and saying, well, what garments do we need for what people do we need? So whether it's on the left and you've got someone that needs a winter garments because they're working in a cold environment, whether you've got some ladies that are working in the team that need PPE, you might have persons working in really warm environments, so they might need to wear less clothes and more lighter weight clothes. So making sure that your workforce are protected regardless of the actual weather conditions or climates where they're working, particularly if you've got persons working over a large geographical area who are always going to get differences in climate, and making sure that everyone is protected for the right climate that they're working in, but then also have the right PPE, whether it's high visibility or not high visibility, but also making sure that the garments are correct for the wearer enjoys wearing the garments. We talk about a lot of people about issuing switching suits, the kind of default method to manage arc flash. We speak to a number of people who would wear, going back to that video before, they wear polyester cotton clothing for their day wear, and then when they need to do any switching work, they would change to a actual arc flash suit. But we know people who have been working in substations where an arc flash has happened, unknown to anyone. But in making sure the actual day wear is arc flash rated, rather than having to always rely on a switching suit, because they're heavy normally, they're quite cumbersome, not everyone wants to wear them, so it's the first thing people would forget to wear on purpose to save the discomfort of having to wear one. If we can move on to the next slide. So when we sell a garment, we are actually testing the garment. So again, if you're wearing arc flash PPE, does the garment actually do what the label says? And will it keep the wearer safe? So the video you'll see starting to play on the right hand side there is actually to challenge the integrity of the garment. So when the garment is finished and made, before it goes to marketplace, it has an actual mannequin test. This is mandatory in Europe if you are certifying to the 61482-2 standard. So if your garments are actually arc flash certified in Europe, so not a -1-2 or a -1-1 standard, then a 61482-2 standard, which means it's been certified and it's had a mannequin test like you see in the video there. And that's to make sure that actual fact when the garment is made together as a combination, it's actually going to stay intact. After it's happened, you're going to be able to undo zippers and Velcro fasteners, etc., and actually get out of the garment, because the garment would still retain an amount of warmth. So challenging the integrity of the garment rather than just relying on a fabric test or a fabric rating is absolutely critical, because otherwise you can't guarantee that the garments will protect you in the moment of need. Next slide, please. So we referred to before about arc flashes taking place when people don't understand there's a risk there. We'll see on this video here playing now. We've shortened this video down. It's available on YouTube. Anyone can view this. We've shortened it down a little bit because it's a little bit too long. But ultimately speaking, you can see here, there's obviously a problem, but there's actually no operation of the equipment here, but something doesn't seem right by the video. But obviously, people will say we don't work live, we're not changing the equipment, so they could be exactly the same position as what the person here is in the screen here, where they're not working live, they're not touching the equipment, but there's obviously a problem. And in this situation, what happens if the equipment fails on its own accord? So there we have the arc flash, and there's no PPE on the person. You can see they're wearing short sleeve garments, no face protection. No, so again, going back to the safety principles, obviously, yes, wear arc flash PPE, but also if there's something doesn't seem right, rather than fishing around to find out, maybe make sure you get proper protection policies put in place and authorizations put in place and investigate what the issue is, rather than just having a guess. Move on to the next slide, please. So then moving on from that is looking at the actual smart habits. So making sure, so as referred to before, making sure that things are labeled up correctly. So Dan mentioned before about making sure the right location. So having the location listed properly and clearly on the labels, system voltages, things like that in there. And then actually making sure that the PPE label's there as well. So as a double check, so it's kind of a precaution. You can have a label, but when you're dealing with that for PPE, something to identify so you can really clearly see what PPE should be worn. So this may be an access to a substation like you see on the image here, and it might be a minimum requirement for substation entry. So it's basically you go into a substation, this is a minimum requirement. A lot of companies that have a minimum requirement, but actually making sure that's visually impactful to the actual wearer or the person that's actually going to enter that substation. It's just another secondary reminder that you are walking into a hazardous area. This is the PPE that you should be wearing as a protection against the hazards that may be occurring behind that sub door. And the next slide there delves into it much deeper. So again, this is a more label specific for the actual panels. So you're basically putting your warning label on there. So it's an IEEE 1584 requirement for the labeling. Also, labels are listed in NFPA 70E and CSA Z462, but you've got things like working distances on there, incident energy, arc flash boundaries, hazard risk categories. Generally speaking, hazard risk categories are frowned on when you've already got an incident energy, because you should go by the incident energy rather than the risk category. So if, for example, the incident energy was 12 cal rather than 16 cal, the hazard risk category would tell you to be in a category 3 PPE. Category 3 PPE is, 25 cal and upwards. It's a lot heavier than a 12 cal garment would be. So you might have a 12 cal label wearing 12 cal top and bottoms and a 12 cal visor and balaclava or a hood would be a lot lighter weight and easier to wear than a 25 cal category 3 PPE product would be. So understanding what the incident energy is critical in making sure the right PPE selected, and obviously then also giving you the shock protection there as well as needed. So obviously shock hazard when the covers are removed. Generally speaking, we see a lot of times people will do switching work where they've got insulated gloves and leather overgloves on to do switching works. But ultimately speaking, if the actual equipment is intact and it's in good condition, there shouldn't be a shock hazard when the covers are closed and panels are closed. But it's there as a reminder to make sure you understand the risks. And then having that image of the PPE next to that is then basically making sure, as a secondary check to make sure the actual wearer is understanding what PPE they should be wearing to actually operate that equipment. So that if worst case scenario, the equipment should fail during operation, the actual wearers are protected from the risk of chronic failure. And the next slide on from that. So again, just another example of a warning label and the PPE requirements for that, just as a visualization to make sure that people are wearing the correct PPE for the job that's on hand. And then going further on from that on the next slide is then looking at how you help identify matrices for businesses. So if you are in a situation where you may not have a label, you may need a template, something along the lines of NFPA category method or the CSA Z462 category method to identify what art protection you need. So these are booklets or books that you can buy online. You can buy online versions of them online. So if you've got a large site or a lot of facilities and you can't afford or haven't got the time to actually put in place at the time an energy study, that might be your end goal. But if you wanted something more immediate, something like NFPA 70E, CSA Z462, both of those have category methods in there, which quite easily pick up normal information that you can get from switchgear panels and then give you an idea of what PPE you should wear, and always on a conservative side. So wearing that PPE, you would be protected well and truly in those situations. And then obviously, so ultimately speaking, get the matrix right, get the templates right, switchgear labeling, and then make sure that the teams are drilled and understand how to operate and how to work around electric equipment, and you're in a very, very safe situation, making sure that the people you're responsible for or yourself, you're going home safe at the end of a shift and day. And over to you, I think now, Dan, is that right?
Yeah, back to me. So we've considered the hazards beforehand. We've done the pre-entry check, so we've been outside what to consider, what to do. So now we're at the door. We'll play a video where these guys and kind of just talk around it, but we've done taking into account the considerations of what might be in there. You'll see in this video now they're preparing to go into a HV substation, so they're making sure they're the right place, they've got the right keys, they've got the right PPE on for the tasks that they're doing, so it's for a non-invasive survey in this example. Got some clear communication going on between the company safety person and the engineer going in. They're going to partially open the door, use their sensors, conduct a visual, check for any unusual smells, like things like burning that wouldn't normally be there, any unusual sounds, so switchgear in distress, maybe a hissing, fizzing, or a popping sound if you're starting to have a switchgear in distress in there. And again, once we've done that, we'd now access the space. But that's a classic example of linking back to that video. I think it was on item number 6 for Anthony, the video where the guys go into the compartment and there's something clearly wrong in there. He's walking around conducting a visual, trying to identify what it is. We would term that as switchgear in distress. There's clearly something wrong, and we know equipment systems aren't designed to be dangerous, but when they are dangerous, they're more likely to fail when we take them out of their normal states when we're switching. So often the consideration would be to people with less training or experience that if they identify equipment in distress or switchgear, things like that, to try and operate it to make it safe, but that's not the recommendation. So in that eventuality, you open the door, you hear indications of switchgear in distress. The correct process would be to secure the substation, raise the alarm, and then in a steady process, try and disconnect that from other means, so from another place. But that's obviously what's gone on in that other video, and you can see the outcome of that, where the person's interacted with the gear, and then it's resulted in a flashover. So hopefully, in most of your substations, you wouldn't come across that. So we're now going to then open the door fully to improve ventilation, let additional light in, and improve our access and egress route, so we know where we're going, how we're getting out. Once inside, again, do the same things, your visuals, equipment integrity, does everything look all right? Is there any signs of any leaks, any moisture, unusual smells, unusual sounds? Again, that switching in distress thing, like fizzing, hissing, popping, something that doesn't sound right. Are there any flags on the switchgear? Is there any signs of equipment in distress? Any signs of vandalism? Again, often we won't go in these spaces. Is everything that should be there? Is the earthen or the grounding arrangement still there? So if it's copper tape or aluminium tape, often these might be taken away for other means, and they're in place for your protection in the event of a fault, for that fault current to discharge to earth or to ground long enough for the protection to go. So if they're not there, you're at risk within that substation. So these are the things that you need to be keeping an idea out for.
Particularly missing copper and earthing is obviously a big theft risk globally. So, and often it's exposed and easy to access for
Easy to take.
people that are untoward. So yeah.
And then finally, I can't emphasize it enough, the battery tripping units, just to make sure that they're healthy, that they're turned on and that they're functional. I've been in so many substations where they've been turned off. So there's actually no BTUs in place. And again, it's down to that competence of person. Someone might have been in to do an inspection, knocked off the supply whilst they do the inspection, to then do a flow check at the end to see what the that it's holding the voltage within the batteries, and they might have just forgot to turn it off. And it's such an important bit of equipment. It's there to, again, to operate the protection relays in the event of a fault, which is when you want it to operate. So the BTUs are such an important thing for your safety and for the loss prevention risk management side of your business as well. So hopefully that's been informative. I know there's a lot to go through, but key takeaways is that our electrical substations contain hazards within. We've got to consider all of these when planning entry, depending on what the task is for, making sure that all those hazards and the things that are outside of your control form part of your planning. The risk's always there. It's important to combine your mitigation techniques, so whether that's PPE, engineering controls, physical barriers, limitations within the documentation. We've got to combine these to keep people safe from the risks. So next part of the journey is going to be the HV switching and control boundaries. Didn't come up very well. So just before we go on to the Q&A, if you do have any questions, or if you wonder, if you're unsure if you've got any operational restrictions on your network, get in touch and we can set a session up. You might have seen it advertised, but we are having an electrical safety conference this year in the UK. It's the first one. US is going to be later on in the year, but we're having a one-day event on the 9th of July in London at the Royal Institution, where Faraday once was, walking before us. So it's a really iconic venue. His workshop's still in the basement, actually. So it's yeah, really good venue. We've got some good speakers lined up, and it's a non-commercial event. If you're interested or you want more information, get in touch. Be good to see you there. And just finally, following on from the USA conference that we had in October, we've continued with the attendees and the panelists that were there to have a monthly call where we discuss key hazards in electrical safety. A lot of these around construction, commissioning, data centers. There's quite a wide range in there. If you're interested in joining, we can let us know and we can get you the link. We have them once a month online in Zoom, and there's some really good discussion points and information sharing from some of the key vendors that attend there. So yeah, that's all for today. Thanks very much. Have we got any questions in the Q&A, Ben?
Yes. So let me just quickly read through them now. Right, so first one is an offline question which was submitted prior to the session. So this is from Guy from Vertiv. I'd like to know if there's a minimal legal qualification for entry to HV areas and what is felt to be best practice or minimal standards.
Does he say what for or just general?
No, I'll read it again though. I'd like to know if there is a minimal legal qualification for entry to HV areas and what is felt to be best practice or minimal standards. That's the only
Um,
context.
no, not so much. So for that one, again, it's going to be task specific. I mentioned earlier on that you wouldn't, people go into substations for non-electrical work, so it might be for cleaning or painting or um, weed control within compounds, things like that. And obviously, we've got to take into account the risk that's there, but it's got to be reasonably practicable, the approach that we take. So, the safest option would be to just turn everything off. But in reality, we've got to consider what are the risks? Can we achieve safety by limits, as an example? And more than often than not, we can. So things like if we are doing weed control in compounds or taking a meter reading, isolating everything wouldn't be reasonably practicable. So from a training perspective, we wouldn't expect someone doing specific tasks to then have, an electrical background, a high voltage background, do a HVSAP course or a switching course, but they need to have sufficient information, instruction, and training to be aware of the risk and manage those hazards. So typically, would expect some kind of HV awareness. If HV is the risk, obviously, if it's a HV substation, some kind of HV awareness. Now you can get courses on that through external providers. But if it's specific HV risks, a lot of companies have internal ones that they will deliver to the vendors going in to say, this is what you need to be aware of, and then they'll control the limitations within those compartments by issuing things like an access document, like a limitation of access in the UK. But there's similar other places, limited work certificates, things there to say what they can do, what they can't do. So it's not a specific course. It would be a combination of those to manage what the guys are doing.
Good stuff. Thank you, Dan. The next one. Do they still put the ball in the pipe indicators to indicate flooding in substations?
I haven't seen any for a long time. Not no, I don't think so. Good question.
Never mind. Next one. What mistake do you see companies make most commonly when choosing clothing for their teams?
Um, I mean, I'll hand this over to Anthony because he's probably been around the longest. But the questions that I've kind of got, it's um, I get asked for a switching suit every time. Can I get a price for a switching suit? And the questions I always go back is what are you doing? What's the tasking? And often, yes, they are switching, but in addition to that, the removal covers to do infrared surveys, as an example. They're taking oil samples from transformers. They're working. So, like for me, the biggest risk is when they're doing like removal of covers from panels live on LV equipment to do thermal surveys, because there's a chance of dropping the cover into the under the live buzz bars or dropping bolts in and things like that. That's a higher risk than just putting on a 40 cal suit to conduct switching operations, because you need something to align with your policy. So I would say the
Yeah.
biggest issue that I see is it's more of a tick box. We've got a risk of HV, so we'll buy a switching suit, but HV is normally planned. It's normally you'll do a switching program. Ideally, you get someone else to check it, and you go through that process. LV is always LV or live working is always my biggest concern, because it's typically less controlled. It's more regular, and guys often go, they're not going to go out their way to apply PPE, so they often I'll have a quick look, and that's always been my biggest concern. But I'll chuck it over to you, Anthony, rather than me taking every
No,
question.
it's good, and often in LV as well, you generally get a higher fault current, and like you say, there's not the same restriction on access, and you'll have a lot more people would just tend to think that LV is a lot more relaxed and easier to operate. But obviously, with that factor comes obviously with a higher inherent risk, slow protection settings that. And the other thing as well is often people will look at the actual clothing that's being worn and focus on the clothing, and then completely forget that people have also got faces and hands, which aren't generally covered by normal day-to-day clothing. So making sure that your gloves for your hand protection is actually matching or correct what the actual risk is, and also making sure the face protection or head protection is correct as well, and matching the actual PPE ratings. And then, as I mentioned before as well, is when you've had an instant energy study done, is then defaulting to a PPE category. You're kind of writing off the money that you spent on an instant energy study by just going to the category. You could go to the category method by spending like 70 quid or whatever, 70 pounds on a NFPA 70 standard and using the category method from that. So when you've done instant energy study, use the instant energy information. And if you don't know how to actually use that to the most practical effect, then by all means give us a shout, let us know. We do a lot of times, we help clients out. We've got a massive amount of equipment, all kinds of instant energy ratings, helping them understand what PPE they need in certain areas. And then, as I went back to before, drawing the templates up for them, the matrices, to help them understand at what points they should what PPE. So yeah, it's making sure that you actually wear the right PPE for the job and you actually got all PPE covered, not just like down to the tick book exercise where you've got an art flash suit, but actual fact you've forgotten live gloves when you open up panels and things like that. So hope that helps.
Good stuff. Thank you. Two more questions and we'll wrap it up if that's all right. So the next question, is measuring in calories a common standard?
So normally energy is measured in joules, but in the US it's measured for instant energy, it's measured in calories per centimeter square. So it'll be a calories per centimeter square heat energy that you'll receive as a rating. And then when we're actually testing PPE, we're getting a rating per calorie per centimeter square rating for our PPE, whether that's a arc thermal performance value or a helium or a energy breakthrough threshold value, but it's always in calories per centimeter square rather than joules. In Europe, joules will sometimes be used, pretty much because there's a bigger gap between the art protection class 1 art protection class 2 PPE levels. There's quite a big gap between that. So some companies will actually test their garments and get a joule level of energy protection for the garments, and then you can actually, there's some software in Europe, I forget the name of it right now, but it'll give you an energy rating in joules, which you can then try and match it with clothing that's rated in joules as well. But it's not.
Is it Dig Silent? Is it?
Say again.
Is it Dig Silent software?
I don't know. I'm not too sure. It could well be. Probably more knowledge than me on that one. So
good stuff.
We'll try and
thank you. Thank you for that one, Rob. Last question, Dave. I've seen you've submitted two here, so we'll get them both answered at the same time, if that's all right. So this is from Dave. For either of you, best way to determine LV or HV switch room access PPE requirement for non-invasive access. That's the first part of it. We've had the art flash assessment for the switch panel, etc. How do you differentiate this for the room?
So the room is more looking at a base level requirement. So if you went back to that video that Dan showed of the two guys in high-vis going into a entry into a substation, they were taking readings and measurements. Panels were all closed. So in that respect, you might just require making sure that if something happens, your clothing isn't going to catch on fire. Hopefully, if everything sounds okay, smells okay, and like Dan said, there's no equipment in distress. You'd like to think that the actual equipment is in its normal operating condition and is unlikely to arc. In the video that I played, there was obviously an issue. So understanding if there's something doesn't seem normal and seems abnormal, then you would maybe step back and classify what might be the cause here and what PPE you might need to wear. But as a general rule for accessing HV switch rooms or LV rooms, you might just have a general base level of art protective PPE. And normally we just generally try and look at making sure all skin areas are covered with some form of protection.
Yeah, it's that approach boundary, isn't it? A lot of it's around the approach boundary. So a lot of customers will mark the approach boundary based on probably the highest instant energy. So you've got a clear demarcation in the substation, yeah, where that is, and obviously that's where you get down to 1.2 cal. But typically you're going to encroach that on you. So it's that assessment around the type of gear, whether it's enclosed, whether you're doing invasive or non-invasive works, things like that. But if it's for general just access and you're outside that approach boundary, then again it's just determining what like minimum level of protection you have in place for that. So there's no difference between HV and LV. It's just purely based around fault energy and instant energy.
Yep.
Good
That
stuff.
helps.
I think that rounds it up. Thanks for that one, Dave. I'll pass it back to you guys.
No, it's been really good. I think on the last couple, there's been a lot of information going out, so it's been very nice to have people coming back and giving us some inputs. It's really good. I think on our electrical safety calls, we see a lot more of that, don't we, Ben? Where we're getting experiences from people where we unmute them and things like that. So I think it's been quite nice getting something back. So appreciate
Yeah.
everyone for joining.